Afternoon, George. Welcome back to another episode of Ask the Expert.
Good to see you again, mate.
I wanted to do something slightly different. This time we've talked a lot about different applications in mining, etc., but haven't really talked about a real life example. So we've seen about this case study that we have in front of us at the moment. Can you explain a little bit more about what it's about?
Okay, so this is a submersible pump from one of the mine sites in South America. And it's actually a pump that suffered a significant amount of erosion and corrosion. There's acid runoff into this sump, and that's eaten away the impeller, the sand. It's actually abrading away as well. So you've got, it's almost like a perfect storm for the pump.
Wow.
It's really suffering. And the guys in Latin America have been done really well in actually applying ARC 855 to actually repair the impeller that was deemed going for the scrap bin, and then a top coat of 858.
So you've got sliding abrasives as well as some impact and acid as well. So you've got chemicals as well as sliding abrasion there.
And it's important of being able to put a top coat on as well, because the top coat can be more corrosion resistant than the material that we use for abrasion resistance.
So looking at the photo, I can see here that impeller that's a mess. You'd be throwing that away.
Yes, that was meant to go to the scrap heap, but quite often, and after COVID as well, pieces of equipment like that can actually take 6 months to actually get across the country or across the world to be able to get into the plant. Customers can't wait that long.
Sure.
So it's quite often that doing a repair like this is the only way forward, because it could take maybe 2 or 3 days after the equipment is pulled apart. You do the repair work, any machining that's required, any top coating, and you can have things back in service within a few days rather than months.
Yeah, wait for months for it.
Yeah.
Also surely that would also be cheaper then. Like if I was to buy an OEM impeller from somewhere, that could be quite expensive.
You'd be saving a lot of money on having to get a new one, but also being able to repair. Equipment that's repairable is certainly, more desirable, and this is what our composites are all about. It's about repairability. Yeah. Once some of the composite wears away, you can repair with a fraction of the material again and provide another top coat. So you keep on repairing the same skeleton, so to speak.
So if I think about this a bit further, then is it possible, rather than have to have a super duper material like super duplex, can I just use a cast iron or something and protect it using a coating, perhaps?
Well, it depends. If you actually are able to completely protect the metal from having acid get into any crevices or any joints, if you can do that, yeah, sure.
Okay.
But that becomes more important then, to be able to make sure that you can actually coat every single part that's going to be exposed, so that there's nowhere for the material to actually creep in and start eating away at your substrate.
Yeah, that's an important point, isn't it? Yeah. So I guess that's application specific.
Absolutely.
Going back to this particular case study, though, it looks like we've been able to recover this product and rebuild it and put it back into place again in such a short period of time. I think according to this, they were able to do it in a couple of weeks. Or no, in a few days.
In a few days, yeah. And the savings are significant, because pump parts aren't cheap.
Yeah, that's right.
Very expensive.
So were they able to do, like with this one pump, surely they've got more than one pump in this plant, from memory. I think it looks like they've got a few. So I guess they did them all.
They've got a few, and that's why the savings are over $700,000 US.
$700,000 US for the year.
Yeah.
Wow.
And that takes into account downtime and, of course, maintenance costs.
Oh yes, of course. Yeah, that's true. Do you think the pump will last longer now that it's coated?
Yes.
Yeah. Yes. So we'll be able to withstand more throughput, dare I say? Well,
there's efficiency gains to be made as well.
Mm-hmm.
I mean, we spoke previously about efficiency gains using the 858 top coat and having that thick satropic surface. That's nice, smooth surface, and that in itself is also another improvement, another way to for this to be a better return, or bear a better return on investment.
Yeah, your return on investment. Very good. Thanks, George. It's a good insight. Do yourself a favour. Go and check out this case study, because it's really a fantastic result.
Yeah.